again, one is clustering, the other one is recommendation system. And then this one which I was talking about, you must have noticed that people keeping product next to each other in your malls also. If you go to any grocery store or any big malls, and then you're going into you're buying some grocery stuff, you would notice that cold drinks and ice creams are kept next to each other, because it's just that it's a frequent, like whenever someone buys bread, they will either buy milk or they will either buy jam, right? So it's very frequent that people will be buying this kind of items in pairs, right? So this is called as association rule. Okay, but in our course we will be looking at clustering. Okay, because a lot of in interviews and a lot of opportunities outside world, like outside in this world, we would notice that people would be hiring for clustering. And for recommendation system, we generally, people will train you in like working itself, but there will be very less opportunities in recommendation system, because like Amazon, Flipkart, there are some big shots who will be looking for recommendation system, but there will be a lot of companies who will be looking only at the candidates having clustering knowledge. So based on that, we have designed the course. So this is different types of unsupervised learning examples which I have given you here, and we'll go with clustering example. Okay. Now to give you one more example on clustering. So this is a mechanical example which I have given. Now let's take a different example here. In this case, if you notice, okay, let's say that you have the data for SAT scores, or let's say CAT scores, their work experience and their domain for their work X. Let's say that you have these three features for different records, and then you have some data here. Okay, and you would notice that, let's assume that there are a lot of IAMs, right? Let's take only IAM A, B and C. Okay, now if you notice, there will be a lot of different data here, and let's say that very high CAT score, okay, very high CAT score and less work experience with any domain would be clustered in one group. Let's say that all these candidates would go into IIM Calcutta. Now let's say that low CAT score but very high work experience. So this kind of data would be clustered into one group. This kind of would go into IIM Bangalore. And then very high work experience and very high CAT score, this kind of data would go into IIM Ahmedabad. So what I'm trying to tell here is, you will try to find the similarity between the data and then you cluster them. How do you find the similarity? If you remember the KNN algorithm which I've talked about, which was K nearest neighbor. So it's more about calculation, right? Sorry, distance calculation. Here also we will calculate distance between different records. Okay. Now once we calculate the distance, but here the distance calculation would be different. The calculation formula might be same, but the points for calculating the distance would be different in this algorithm in comparison to KNN. Okay. So you don't have to worry about that much. We'll go into that details also. But the basic funda is distance formula again. Okay. Now let's go there to the presentation. If you see that we have some data set here. Okay. And let's say this is our X1 first feature and then second feature. We have plotted our points, all our data which we have based on the X1 and X2 value. Okay. And now if you notice, these are clustered into one group, these are clustered into second group, and these are clustered into third group. Now the challenge for us is how to cluster this data. That's the first challenge. That is based on distance formula, right? That is one thing. Second challenge is how to decide how many clusters or how many groups we want. That's the second challenge. Okay. So if you notice, clustering is one of the most common exploratory data analysis technique used to get an intuition about the pattern of the data. Okay. So this is also can be used as exploratory data analysis, but most like this is a machine learning algorithm. You can either use it as an exploratory data analysis, or you can use it as a machine learning algorithm, and then you can find the insights out of it. But anyways, whenever you're trying to find insights, anything which you are playing around with the data would be exploratory data analysis, right? So you can perform at the beginning also if you want. But then before doing this, you should always find mean, median, and then 4 business movements, try to draw the graphs and try to understand the data in a better way. Now the second point what we are trying to tell is, it is a task to create subgroups within the data set, which we have already understand based on the similarities. And then homogeneous subgroups within the data are created in such a way that data points in each cluster are as similar possible to each other, okay, based on the similarity measure. And this similarity measure could be based on Euclidean distance formula or some other measure. And then here in clustering, we are not training the any input data with output data, as there is no output, which we have already discussed. Clustering is a method to find patterns without any output feature that we have already discussed. So let's go into the details. So in clustering, there are a lot of different methods for clustering. The first one is k-means clustering and the second one is hierarchical clustering. There are three more which are fuzzy clustering, density based clustering, which is DB clustering, and then model based clustering, MB clustering. But those are advanced type of clustering. You don't have to get into much details because people generally use k-means and hierarchical clustering only. But most of the people and most of the organization uses k-means, so don't worry. So in today's session, we will be looking for k-means, and in the next session, we will be looking for hierarchical clustering. Okay. Now, k-means is an iterative method, guys. Okay, it's an iterative method which we need to understand here, and how it decides the cluster. It's based on certain rules, and if we can understand these rules, it would be very simple. Okay. First point in this iterative algorithm is define the number of clusters required for the data set with n data points in a data set. For example, you have this many n data points here, right? And then let's start with k equal to 3. Okay, we are starting with, let's say k equal to 3, or let's say k equal to 2. It's up to you. But let's start with some random number for the k value, k-means algorithm. Okay, let's start with a random k value. And then the next point is, for example, for this kind of data points, now the first step is define the k value randomly. Okay, in this case, let's take the value of k equal to 3, because by looking at the graph, it is quite simple that the value of k would be 3. But let's anyway start with k value equal to 3. Okay, we can start with 2 also. K is equal to 3, then we have to randomly allocate 3 centroids here. Okay, let's say that for me this is one centroid C1, let's say this is C2, and this is C3. So far so good, guys. C1, C2 and C3. Now what happens is, all the data points here would try to calculate the distance from C1, C2 and C3. Okay, all the data points would try to calculate the distance from this C1, C2 and C3. Now the points which are near to C1 would come under C1, let's assume. The point which are near to C2 comes under C2. The point which are near to C3, that comes under C3. Okay. Now what happens, once we have decided that, let's say that for a second step would be, let's say based on the second step, or based on this centroid C1, C2, C3, let's say that this is one cluster. Let's say this is one cluster and this is one cluster. Okay. So this is what we are getting the clusters now. Okay, based on the randomly C1, C2, C3 centroid values. Okay. Now, once we get these 3 different clusters, we do not have to stop here. We have to keep on doing this process. Okay. Now, the second iterative process here would be to calculate C1, C2 and C3 again. So now for this cluster, what would be C1? You all know what is C1, what is the formula of centroid? If you have only X1 and X2 features, and then let's say you have 5 records under this cluster. Now let's calculate the centroid based on these clusters. You understood how we got these clusters, right? Based on the distance formula. These all points were very near to C1. These all points were very near to C2 in comparison to C1 and C3. And these points were very near to C3 in comparison to C1 and C2. So that's how we have come up with the 3 clusters. Now again we will calculate the centroid. How would be the centroid calculated? Let's say that, for example, we have 5 records for in first cluster, let's say, and so on. Okay, then sigma of x1s divided by number of observation, comma, sigma of x2s divided by number of observations. So that's a simple centroid formula which you can use it. Now again you will get a new centroid value. Let's say that centroid 1 is now here, centroid 2 is here, centroid 3 is here. Okay, let's assume. Now again these points, all the data points will calculate the distance from C1, C2 and C3. Okay, and then the points which are near to C1 will come under C1, points which are near to C2 comes under C2, points which are near to C3 comes under C3. Say for example, now we are in third iterative process. Once it calculates the distance, now let's say that these points are coming under C1 based on the C1 location. These points are say coming under C2 and these points are coming under C3. Now what would be the next step? Again calculate the centroids for the new clusters and then calculate the distance, again form the new clusters. Right, exactly. So it's an iterative process. Calculate the centroids and then based on the distance again form a new cluster, and for the new cluster again form a centroids. So you have to keep on doing this until unless your solution is converged. What do I mean by solution converged? If you have to keep on doing this until unless your cluster, the data points in clusters are not changing. For example, if this is one cluster, this is one cluster, this is one cluster, and then again if you calculate the centroids and then distances and then again form the clusters, you will notice that these data points are still remaining under this cluster, these data points are still remaining under this cluster, these data points are still remaining under this cluster, and the positions of C1, C2, C3 are not changing with iterations. And then we call it as converge. Something like in our mechanical also, right? If we want to tell that our simulations are converged, we look at the continuity equations and Navier-Stokes equation, right? I'm not sure if you're coming from the thermal background, but let's take a very simple example. Temperature. If you want to say that for one particular component, the temperature has achieved its converged state, then what do we mean by that? The temperature is not changing with iteration, right? Similar to that, your data points under clusters are not changing now, and the centroid positions are also not changing. So this is how we conclude our k-means 3 clusters. So now this was done by 3. Now the second task is how to decide the value of this k. In general, what we do is we'll calculate the values of this. We come up with the clusters of k-means with 3, 4, 5, 6, 7. Let's say we are trying from 3 to 10. Is there any way to reduce the number of iterations? It's a good question, but yes, there is a way. For that, you have to do very good exploratory data analysis. For example, if you have done a very good exploratory data analysis, you would come to know that these points are very near to each other by itself. By looking at the graph, by doing a lot of exploratory data analysis, you would come to know that these points are very similar. These points are very similar. These points are very similar. Then what you can do is you can randomly assign your C1, C2, C3 in such a way that instead of assigning this as C1, you can assign the C1 point as taking all these points and then calculate its centroid, and then you will assign that as C1. Instead of taking one of the points as C1, if you have done a very good exploratory data analysis, you can identify those points visually, and then you can tell that this could be the centroid would be for this would be the mathematical centroid calculation formula. Use that and then take that as C1 and assign all these points to that cluster. Okay, of course you can reduce the number of iterations, but then this is very simple to visualize when you have 3 features. But what if you have 4, 5 features? Okay, at that point of time you have to do a lot of exploratory data analysis to understand the data. If you are able to understand data, no, believe me, this machine learning algorithms will be very simple for you, because what this is telling is the same thing what you will be doing in exploratory data analysis. It's just that the theory or the insights which you will come up with in exploratory data analysis, that will be validated by machine learning algorithms. Simple. Okay. So what I was telling is, instead of 3, now you have formed of 4 clusters with the same data points. Let's assume with the same data points, you have formed the 4 clusters. We have formed a 5 cluster, 6 cluster, 7 cluster, 8 cluster, 9 cluster, 10 cluster, or so on. It's up to you. But I generally do it from 3 to 10 or 2 to 10. Okay. There is no sense of making one cluster, because for one cluster, all the points will be coming under one big cluster. So there is no point of making a one cluster. Okay. It's like a data set itself. So do it from 2 to 10. And then once your solutions are converged, calculate the sum of the squares. Sum of the squares in the sense, sum of the squares of the distances. For example, now your final graph would be something like this. K value 2, 3, 4, 5, 6, let's say. And then sum of squares, okay, of the distances. Okay, now let's see that with this data point, let's say with this data point, if I had 2 clusters, and I have finally converged my solution and I got C1 and C2, the distance sum of square, if you calculate the distance between all the points and its corresponding centroid for the given cluster, and then square that, because in the formula of distance you will have a square root, right? You can have a square root if you are using Euclidean. If you are using absolute distance formula, then you will have modulus. So just take a square of that and then add all the distances and then plot here for corresponding to, let's say, your sum of the squares of the distance is somewhere here. Okay. Now, can you tell me, if I have 3 clusters, so let's take a new graph here. Let's say that instead of 2 clusters, say that you have a 3 cluster like this. Okay. Now, can you tell me, with 3 clusters, the distances would be decreased or increased? Exactly, because we are trying to form high number of clusters, so the distances, the homogeneity would be more within the cluster, so the distances would come down. So let's say for 3, the sum of squares is somewhere here. For 4, it is somewhere here. But as you keep on decreasing, no, you will notice the sum of squares would not decrease that much. It decreases, but it will not decrease that much. So say for example, let's say that this is the trend looks like for some of the squares distances with respect to K value. Let's say that after 5 you notice that the distances are not decreasing much. Then we say that the value of K equal to 5 is an optimal value for clustering. So this is called as elbow curve or scree plot. But why is it called as elbow curve? If you notice, this looks like our elbow. Okay, from here to here and then from here to here, like an elbow. So initially it will decrease rapidly and then it will not decrease that. It will decrease the value of sum of squares gradually. Okay, so what's the point? What I'm trying to make it here is, this would be the optimal value of K. Okay, because after this the distances values are not decreasing much. Making sense, guys? Okay, so this is what it is mentioned here. The same point which I've talked, that is the same thing which is mentioned here. I don't want to read this. You can read it if you want. So the same steps are mentioned here. Okay, let's say that there are 5 data points and then you are randomly assigning some 2 centroids, but you can assign these two centroids as the data points itself. For example, A is 1 centroid, D is 2nd centroid. It's up to you. You can randomly assign these 2 centroids and then calculate the distances, come up with a new centroid. With the new centroid, calculate the distances. Again, with this new distances value, come up with a new centroid. So keep on doing this until your centroid position or the data points within the cluster are not changing. Okay, right. So this is all which we need to understand. So you can also write this algorithm from the scratch. Okay, very important thing. If you want, you can write it from the scratch also. Now, as I told, my applications of clustering So clustering has a large number of applications across various domains. So as I told, recommendation system, market segmentation, social network analysis, search result grouping. So you can do a lot of different applications using this clustering. Okay. So now this is the kind of elbow curve. If you notice, sum of squares is denoted as distortion, and this is the value of k. Ideally, we should not compute the distance sum of squares with k equal to 1, because it doesn't make that much difference, because when k is equal to 1, it says that you are considering all the data points as one cluster. Then there is no use of using cluster, right? Because when we are using cluster, we have to come up with at least 2 clusters so that we can understand the data in a better way. So from here, the graph goes from the value of k, and then it will look something like this. This is called an elbow curve. So by looking this graph, can you tell me what could be the value of k, which could be the optimal value? Okay, if this is the graph, I would choose k equal to 3, because after 3, if you notice, the distortion is not decreasing rapidly. Okay, consider this as your elbow. Okay, and this is where your joint. Okay, so this joint would be your optimal value. Okay, so this is how you can do it. Okay, now I want to tell you something else also here. Very important thing, you can have a lot of input features, x1, x2 and so on. Let's say you have different features such as the price of a car, mileage of a given car, and let's say the dimensions of the car. Using clusters, you're segregating this data, you're forming the clusters. Let's say that you have formed 3 clusters, okay? And in that 3 clusters, you notice that in one cluster, you have all the data points with very high price. In other cluster, you have all the data points with less price, and you have a third cluster which has a moderate price. And you know that you are reading the data from 3 vehicles, say Porsche, okay, Mercedes, or say Maruti. Now you understand that I'm just giving an example. So very high price would be for Porsche, right? So this belongs to Porsche. This belongs to Maruti. This belongs to Mercedes. Now what you can do by this is, you have x1, x2 and so on. You can create your own output data saying that this data belongs to Porsche, this data belongs to Mercedes, this data belongs to Mercedes, this data belongs to Maruti and so on, and you can come up with your own output. And then once you come up with your own output here, imagine that till here it is your unsupervised learning. Okay, you have come up with your own output using unsupervised learning. So this is from unsupervised learning. And your y is 0, 1, 2. 0 belongs to Porsche, 1 belongs to Mercedes, 2 belongs to Maruti. Now, what we have to do here is, now if there is a new data which is coming in, now think in this direction. Whenever there is a new data coming in, you can consider this data as for your training data, and then can be used for your prediction analysis. You can split this data into training and test data set, use this data for your prediction analysis, and then whenever there is a new data which is coming in, predict what could be the y, whether it is 0, 1 or 2. So your final project will be based on this. You will be having a data, you will not be knowing what is your output. You have to do your unsupervised learning, try to understand the data, and then you will identify what is your output. And once you got the output, now there you will be doing your prediction analysis. Okay, so your final project would be based out a combination of unsupervised learning and supervised learning.